So I'll say it multiple times, but the free response assignment today is only problems 1, 2, and 3, not 4, 5, and 6. All right, Connor, start us off. Were you good on the entire front or not?
No.
Okay.
86 is where I started.
86. Okay. What did you try on 86?
I tried U sub.
Okay.
I did 4 minus x squared.
I like that.
I got 2x is du.
Uh-huh.
And then I did u to the negative 1/2 du.
So yeah, hold on, let me catch up. You're right, but so negative 1/2, and then yes, u to the negative 1/2 du.
And then I kind of solved the answer choices, and I got worried that I had done something wrong.
Okay. The pi over 3 and pi over 6 is like if somebody thought that was an inverse sine problem, maybe. So those are probably not right. But so I'm guessing it's either 1 or negative 1. We'll see here in a minute. So what did you do next? Is this where you think with?
I did the antiderivative.
Okay.
That's where I saw the answer choices and I was worried.
So that would be u to the 1/2 times 2, and there's still a negative 1/2 out front. And then here we've sort of been a little casual, nonchalant about limits. I just plain left them off because it would not be right to put 0 and square root of 3 there because those are x limits. So now the choice comes, do I want to change these limits to u limits, or do I want to change this back to x stuff? I think I want to change them to u limits because the test will likely find a way to ask questions that forces you to change the limits. So I'm going to go ahead and change the limits. So let's see, u at root 3 is 4 minus 3 is 1. So the upper limit is 1. And u, if we plug in 0 for the bottom limit, is 4. So this is negative top one minus bottom one. So lots of negatives here to keep up with, which I guess if we had done this sooner, we could have used the negative to flip the order. That might have made things a little easier, but it's going to work out the same in the end. So 1 minus 2 is negative 1, but then the negative out front makes this a positive 1.
Can you do 84?
Mm-hmm. What'd you do first on 84?
Use substitution. I did 3x minus 1.
Yeah, I don't think I would do that. I think I would just...
Oh wait, no, that was my first thing. And then...
You can divide them both by 3x?
Yes, I remember I did that. I just wasn't sure if I did it all right, like the very end.
So, let's see, the integral of 1 is just x. And then, if I view that as 1/3, sort of outside of 1 over x, that way I don't have to deal with the 1/3. The integral of 1 over x is natural log. And from 1 to 2. So plug in 2. 2 minus 1/3 natural log 2. And then plug in 1. 1 minus 1/3 natural log 1. What's the natural log of 1? 0. So that part at least goes away. 2 minus 1 is 1. So I hope I've got 1 minus 1/3 natural log of, whoops, wrote the wrong thing. 1 minus 1/3 natural log of 2. So that one had an algebra step at the beginning. 83. Yes, so that one, just straightforward power rule all the way down. X cubed over 3, x squared over 2 minus x. From negative 1 to 1. So if I plug in 1, 1/3 minus 1/2 minus 1, minus, plug in negative 1, negative 1/3 minus 1/2 plus 1. Keep all those negatives straight. Did you find your mistake?
Yeah, that's the movie.
Let's see, 1/3 plus 1/3 is 2/3. Negative 1/2 plus 1/2 goes away. And negative 1 minus 1 is minus 2. So 2/3 minus 6/3 is negative 4/3.
Wait, I have a question about 84 again.
Mm-hmm.
So where does the other 1 go? Like when it's like natural log of 1 is 0, but it's 1 minus. Like where does the 1 go? Isn't it 1 minus 0?
Yes, but I did 2 minus 1 gives me that 1.
Oh, okay. Why did you subtract this 6/3 from the minus 2?
I did a common denominator. 2 is the same thing as
But why did you
6/3.
get the 2 to subtract?
So I combined 1/3 and 1/3 to get 2/3. Then I combined negative 1/2 and positive 1/2 to cancel out.
Yeah.
And then minus 1 and minus 1,
But it should be.
because that minus sign up front makes that minus 2.
Oh, I'm missing like 4 numbers. That's what's because this makes it positive, right? These two negatives out 3 is negative out 3, which makes it negative. So the negative is 1.
Becomes boring.
Other questions? 88. What'd you try first?
I just don't know.
Let's see. So, is one of these things a derivative of the other? That's almost a trick question because they're both derivatives of each other. So, which one do I want to pick to be u? Cosine, because I don't want du squared. That wouldn't really work. So let's let u be cosine. Du then is negative sine. So I need a negative on that part to make it du. So a negative out front. So negative integral of u squared du. And again, I've kind of been lazy with the limits there, because I shouldn't put 0 and pi because those are theta limits, not u limits. So I either need to switch it or sort of finish the problem and switch it back. I think I want to be in the habit of switching it because, again, the test can ask questions that force you to switch the limits. So cosine of pi is negative 1. And cosine of 0 is positive 1. Now I'm glad I did that. Is there a step that can make our life a little easier here? Yeah, I can use the negative sign to switch the limits, and then it sort of, 2 wrongs make a right. Not really, of course, but 2 negatives make a positive, so we can use that negative to flip the limits, and now it just looks better. So u cubed over 3 from negative 1 to 1. And I'm done with 0 and pi, so don't switch back to 0 and pi. Don't put cosine back in for u. Although if you do, you can, but if you put cosine back in for u, what do you have to do then? Just put the limits back to 0 and pi. So you kind of get stuck spinning your wheels here. But as long as you land at a place where your limits are u limits and you have a u value, or you have theta limits and theta values, but it's easier to just stick with the u stuff. So 1/3 minus negative 1/3 would be 2/3.
And 89 is the same setup as 84. Right?
Yes, good. I was hoping you were going to say that. In fact, I would say it's even easier because that e to the negative x can flip to the top. And you've got a pretty simple integration after you do your algebra. X plus e to the x from 0 to 1. So 1 plus e minus 0 plus e to the 0. E to the 0 is 1. 1 minus 1 goes away, and all of that to just get e. So I guess first I should show this step. E to the negative x over e to the negative x plus 1 over e to the negative x. Right? They have a common denominator, so I'm going to put that denominator under both of them. And that turns into 1. And that turns into e to the x. So if I plug in 1, I get this, but when I plug in 0, I get that, and e to the 0 is 1, so that 1 minus 1 goes away.
Oh.
Right, how about some from the back? Rectangles and trapezoids. We need to do 91 or 92.
Yes, sure.
You have a preference?
We do
91. Okay. Midpoint approximation with 3 subintervals. The area of the shaded region is estimated to be, okay, so 3 subintervals. I wish this wasn't shaded so dark, but 2 to 6. So that's easy to come up with subintervals. 0 to 2, 2 to 4, and 4 to 6. Midpoint means use the midpoint height. So I'm going to add the rectangles. I've only got 3 rectangles. The width is 2. Actually, I can just go one at a time here. The width is 2, and the height would be f of 1. And the second rectangle has a width of 2 and a height of f of 3. And then the last rectangle has a width of 2 from 4 to 6 and a height of f of 5. So I could factor out the 2. That would be the better mathematical thing to do. but sometimes you lose sight of what you're doing if you factor out a 2. So I think I'm going to leave it in there because it reminds me that I'm just adding rectangles. If I factor out the 2, then I sort of lose sight of what's happening here. So 2 times f of 1, let's see, f of x is 6x minus x squared. So if I plug in 1, 6 minus 1 is 5. It helps that I can have a graph to sort of verify that. I don't want to trust the graph, but I can certainly use the graph to verify. F of 3 would be 18 minus 9 is 9. Height at 3 is 9. And again, I can use the graph to make sure that makes sense. 1, 2, 3, 4, 5, 6, 7, 8, 9. Yeah, I think that's right. F of 5, 6 times 5 is 30, minus 25 is 5. F of 5 is 5. 1, 2, 3, 4, 5. Yeah, that looks right. So 10 plus 18 plus 10 is 38.
How did you get those original heights like that?
So midpoint means use the height in the middle. So the first rectangle is from 0 to 2. So the middle would be 1, so I want the height at 1, which would be f of 1. And then from 2 to 4, the height at 3, and then the height at 5. If you have a multiple choice Riemann sum problem, it's probably not much harder than that. The bigger, more complicated ones are usually in the free response section, and maybe free response with calculator. Because if you have 5 intervals and you've got lots of decimals, like you don't want to have to do that by hand in multiple choice. You want a calculator for that. How about 94 and on? Some of those were you okay with 94? No. So, like circle, circle, circle. So I'm pretty sure a circle is going on here. Ellipse. I don't think so. If we graph that, that's only the top half of the circle. And then from -4 to 4, so that would be a semicircle of radius 4. I don't know what it means by a quadrant of a circle. I guess that's a fourth of a circle. What would be an easy change to that integral to make it give you the area of a fourth of a circle? How could you change that integral so that the area represents a fourth of a circle? Yeah, if you made it 0 to 4, then you'd only have a fourth of a circle. So an easy way they could change up that question for future years. (95) If f of x is continuous, okay, it's continuous, but didn't say differentiable. So continuous on a to b. So to really kind of test this, I'm going to make it not differentiable. All right, give it a point in there. The integral from a to b of f of x is f of b minus f of a. Wait, that's not. If you take the integral of f, you should be getting capital F here. So a's out. Although a lot of times students do that, right? They forget to actually take the antiderivative. They just plug in the top, plug in the bottom. But wait a minute, you got to do the antiderivative. B, a to b f of x, negative b to a f of x. Oh, we did that already once today. Like using the negative sign to flip the limits. That looks pretty good. Let's check out the others, but that looks right. D is out for the same reason as A. Well, wait. The derivative of the integral should get us back to f.
Oh, okay, I see derivative. Okay.
So the derivative of the integral gets us back to f. So I'm okay with the f there. So what is wrong with D? They plugged in the top minus plugged in the bottom. If you do the derivative of x, you get times 1, so that's fine. If you do the derivative of a, and a is a constant, that's 0, so that term shouldn't be there. So D is out. C, the derivative of the integral should get us back to f. Oh, not f prime. So if they would throw that out, then C would have been correct. So it is B. I don't know, I kind of like that one because the wrong answer choices were complicated, but the right answer choice was like pretty simple. So hopefully you could get that one right. Even if you weren't sure exactly why A, C, and D were wrong, B looked pretty good. 96, if f is continuous on the closed interval a to b, so I can kind of use my same picture there, then there exists at least one number c between a and b such that the integral of a to b, that's the area, is equal to, let's see, all of these have f of c in them. This is the area equals area thing. So f of c times b minus a is supposed to equal that area. In fact, there's my answer. That's the MVT for integrals. That area equals area. Sort of like MVT for derivatives is slope equals slope. MVT for integrals is area equals area. We don't usually write it this way. We usually solve for f of c. But maybe it would be wiser to write it this way because then the MVTs have a little bit more parallel structure. Slope equals slope, area equals area. '97 is supposed to be an easy one because the derivative of the integral gets you right back where you started. Square root sine of x squared. I'm kind of surprised that's not an answer choice. It's not right, but I'm surprised it's not an answer choice. What do I have to remember to do? Chain rule times 2x. So I think it's D. If you want to plug in the bottom one because you're just used to doing top minus bottom, that's fine, and I bet that's where some of the wrong answers come from. But you have to chain rule pi over 2, and the derivative of pi over 2 is 0. So let's see, sine of pi over 2 is 1. So that's where some of these minus 1s are coming from. But that's not right because chain rule wipes out that second piece. I'm not sure where. Oh, I guess I see where B comes from. If you write this as sine to the 1/2 and you increase the power by 1, and yeah, there's a lot of things wrong with that answer choice.